Hello, everyone. Good afternoon. Today, we're going to take a deeper dive into Creo ANSYS Simulation. A little bit earlier in the year, we did a intro to Creo ANSYS Simulation webinar, kind of showed some of the basics. Today, we're going to look at some of the more advanced functionalities that the software has for us and what it offers. To set just a couple, I don't know, ground rules, I guess. So you're all muted, and it will stay like that for the entirety of the webinar. If you have questions during anything, you can put them in the questions panel or the chat panel anywhere, and I'll see them. And I'll answer those towards the end of the webinar. We'll have a Q&A session. With that in mind, we'll get underway. So overall, we're going to show some of the fuller capabilities of Creo ANSYS Simulation. So we're going to start with an overview, and then go into how simulation setups work, what kind of meshing tools we have, what kind of results definition is available to us. On top of that, we're also going to look at what files are generated by Creo ANSYS Simulation and how you kind of manage those, as well as what the future of the software is, as it's, it was very recently released. It was released in Creo 7.0.2.0, which came out in like October of last year. So it's still new software and has a lot coming to it. A little bit about me and about boundary systems here. My name is Anthony Vetterini. I'm a technical specialist. I have a bachelor's in science and engineering in both aerospace and mechanical engineering, and I've spent a good amount of years working with CAD and CAE tools, this one being the newest. A little bit about boundary systems. We identify ourselves as a technology leader. We're headquartered in the Cleveland area and are part of the global PDSVISION group, which you can kind of see on the map on the right there, where all those offices are. Capability-wise speaking, we do quite a bit. PLM, data management, we have like cloud services, CAD design and consulting, simulation consulting. So we do a little bit of everything. A couple more things about us. In terms of recognition, we've been noted in the Inc. 5000, which is a national award, and Weatherhead 100, which is a business award for the Cleveland area. Accreditation-wise, the biggest thing to note is that we are a PTC Platinum partner, which gives us enhanced capabilities to work with you, specifically with PTC products and implementing things like Windchill, like that. On top of the PTC product line, though, we do work with other software providers, software companies. You can see a list of some of them down here below. A couple examples would be Keyshot, which is like real-life Photoshop rendering, MoldX 3D, which is like mold flow analysis. And then Cymerics, which is a full-fledged like CFD tool for simulation. Those are some tools that are related to simulation that we do offer solutions for. With that in mind, we're going to kind of deep dive into Creo ANSYS here. So a little bit of an overview. This is another product from the PTC ANSYS relationship. So about 2-3 years ago, PTC released Creo Simulation Live, which was the first ANSYS PTC product released. This is the new one, Creo ANSYS Simulation. It's part of the AIM or ANSYS Discovery product line. As you may not know, but ANSYS has many product lines within the ANSYS family. This is part of the Discovery product line. This is an H-element simulation tool. So the other tool for FEA and Creo is, Creo Simulate. That's a P-element tool. This is an H-element tool. This is still based off your CPU. So Creo Simulate Live is based off the GPU. This is a CPU-based FEA tool, so no specific requirements there. It has a 2 to 4 core parallel solution solver. And in terms of what this can do for you, in its current state, we have structural, thermal, and modal simulation support. Now we're going to take a deeper look into what tools do we have available to us and what can we do inside of Creo ANSYS simulation. Well, to start a simulation, it still follows the basic principles of an FEA simulation. So we have to assign constraints for our structural simulations. If we're doing a modal simulation, we can apply constraints if we want. Don't need to, but we can. And if we're working in thermal mode, we'd have boundary conditions that we would need to apply, as that is a requirement to FEA tools. We could then go in and do loads, which or structural simulations. If you're in modal, you would not apply loads as you can't do that, or that's not how the simulation is supposed to be ran. We can go in and assign materials, and so these are directly imported from your Creo Parametric model. That material is there, will be automatically brought in. And you can go in and create your own unique material. Currently, we're limited to just linear isotropic materials. As time progresses in the tool, and I'll show a roadmap towards the end of this, we'll get more access to things like non-linear materials. But right now, it's just linear. We can then go in and define what kind of results we want to look at. If we want to care about a specific surface, let's say the reaction force or maybe the max stress on a surface, we can create probes to do that. And then we can run from our taskbar up here. And so what you'll notice down here in figure 2 is it's a pretty consolidated toolbar. So it makes it a pretty easy tool to actually use. We just really have 2 main tabs: the simulation tab, which is where we do constraints and loads, and then the refined model tab, which is what lets us do some more refinement. Which leads into this slide. So what kind of refinements do we have? Well, we do have idealizations. So we still have the ability to do things like point masses or idealized springs. We have shell elements, and more shell functionality will be coming in Creo 9 in a year. But there's some basic functionalities there. And we still also have idealized beam elements. One thing that is new to or unique to Creo ANSYS is some of the connections. So we do have these new, slides jumped. So we do have these new connections called joints. What those let you do is actually specify how your model is constrained for freedom. So what that means is if you have 2 parts in an assembly, for example, you can specify if one is supposed to be able to move or if one is stuck in space. To kind of explain a little bit further, we aren't able to yet do friction analysis or any kind of contact analysis. Those are coming in the future. But right now, we are stuck with bonded contact behavior. So things are stuck together, super glued, won't move. We also have a contact definition for no separation, which will allow some amounts of frictionless sliding. But overall, we are not able to do things like, applying a coefficient of friction between 2 materials and see how they slide together. That's a functionality that will be coming in the future. But right now, we're limited to bonded and no separation contacts, as well as these joints, which will allow for motion, but nothing with friction. On top of that, we still also have the ability to control our mesh, which we'll talk about here shortly, as well as create surface regions. So if we need to localize where force is coming down on our model, or maybe what's constrained, things of that nature, we can still create surface regions to kind of divide up our model to apply whatever to it. Meshing in Creo ANSYS. So we have a few options to play with our mesh. The mesh resolution is a little toolbar, which is the easiest kind of form to use, where if you drag the mesh resolution to a higher resolution, it will essentially lower the values in the global mesh size to get you a more refined mesh. You can move it to the left and you'll get a more liberal or more loose mesh. We also have the ability to control the specific global mesh values, which are shown here in figure 2. And we also have the ability to actually do local mesh refinement, which is allowing you to basically set the maximum element size on either a specific surface or along a certain edge. Those are things you can kind of control. And obviously we can see our mesh, and that will allow us to go back and change some of these mesh parameters maybe to get a more refined mesh around certain aspects of our model. Now, results definition. So results work a little differently inside of the software. We have 2 types of results. We have basic results and advanced results. Basic results in Creo ANSYS simulation will always get created depending on the simulation you run. So for example, if we run a structural simulation, the basic results we see up in figure 1 will always get created, and so we'll always be able to see those. However, there are other types of results that you might want to see, and that can be created using an advanced result, which we see down in figure 2, some of the examples. So if you're curious with maybe the reaction forces, maybe you want to see any sliding in our frictionless environment. You can see that. If we're interested in other types of stresses, maybe like max principal stress, those are things we need to create an advanced result for. And so that is really the big difference between the two. Is basic will always get created for our simulation. Advanced are things we need to define as the user to see at the end. One other big note is if we want to see like our deflection or deformation and actually see the shape of it, those need to be created as advanced results. So our basic result, displacement magnitude, will just show the values. This deflected 2 millimeters, and you'll see the colors on the contour plot. But we won't actually see the model deflect. That would need to be used. That would need an advanced result to be created to actually see the displacement in the model. Now, past all of the actual simulation aspects, what files are created and what's happening in the background of this. Well, when we save our simulation, we actually are creating a .apr file. And this file can be opened directly, which will open up your full model and all the simulation characteristics. So if you have, all of your loads, constraints, whatever idealizations you might have, all that is stored to this APR file. So, this one file gets kind of large. So something to be cautious about or make sure you know. In terms of file management, this APR file works with WinTool 12.1. On top of that, though, what's nice about Creo ANSYS Simulation is that we do have the ability to import existing simulations. So, for example, if you have a model that was a setup that was created in Creo Simulate, you are able to actually import that into Creo ANSYS. So you'll be able to import like your loads and constraints from Creo Simulate into Creo ANSYS Simulation. Finally, if you're working with like ANSYS Workbench, you do have the capability to actually export our results from Creo ANSYS Simulation into a file that's readable by ANSYS Mechanical. An example use case of this would be is, for example, like a drop test. That's a functionality that's currently not available inside of Creo ANSYS Simulation, but is available in like ANSYS Mechanical or ANSYS Workbench. So for example, you could set up your full model all inside of Creo ANSYS Simulation, export the APR file, or export to mechanical format, and then you'll be able to open that file inside of ANSYS, and it will automatically like import your model, import all of your model setup up and through what you've done in Creo ANSYS Simulation. So it's a nice functionality that works or that helps connect or bridge Creo over into ANSYS. Oh, might I slip on? Nope. So now what's the future like, right? So I kind of explained that right now, it's still new software. It's only about 3 or 4 months old. And so in the future, there are some things we can expect to get out of the software, some more application to it. The second phase, which is planned for Creos 8, 9, and 10, are shown up there in phase 2. So the first one we have is design optimization, which PTC will be rebranding as DOE or design of experiments. So that's a tool that's currently available, in Simulate, but we'll be able to play with dimensions of parts and optimize our design based on our loading scheme. Advanced shell element uses and nonlinear materials will also be coming soon. Past that, so this is looking at Creo 10 and beyond, so two-ish years out. Some of the more functionalities that will be coming are going to be buckling analyses, transient analysis, so time dependent, large deformation, and things like basic drop tests and pre-stressed analyses will also be coming in Creo 10 and Creo 11, so about 2 or 3 years out. But the partnership between PTC and ANSYS has been growing, and there's also other functionalities that will be coming in the future. One example is maybe like an electromagnetic simulation. That might be coming in 3 or 4 or 5 years, but as the partnership between PTC and ANSYS grows, some of these new or unique tools from ANSYS will be able to be used inside of inside of Creo. So I'm going to show a short little demo of the tools available to us. So let me open up This here, yep. So right here, we have this motorcycle open. And so I'm gonna kind of step through what was created here and how it was created. So in our constraints, which we see up at the top, we're able to fix and enforce restraints in certain directions. So our fixed constraint will fix a surface, in all degrees of freedom. But if we wanted to be a little bit more specific, right, like free in X or free in Y, we can use displacement constraints, which will allow us to define our degrees of freedom along an axis or prescribe a certain value of displacement. We also have our functional constraints, being planar, cylindrical, and ball constraints, which are just pre-formed displacement constraints. So they're just displacement constraints that are already defined. We also have a frictionless constraint available to us. Past that, what we've done here is we've applied loads to our model to simulate 2 riders, and we've distributed the 2 riders' loads over a few surfaces. We have a load for the engine coming down where the engine is bolted in, as well as our fuel tank. So we have some loads pushing down, and other loads that we have available to us, our pressure, moment, gravity loads, centrifugal forces, a temperature load. We also can apply linear acceleration. So those are our loads available to us. Next thing we can look at are contacts. And so what you see here is that there's a bunch of contacts that get created between all the parts in this assembly. It's a very large assembly, which we see at the bottom left in the model tree. All these sub-assemblies have sub-assemblies and so on and so forth. So there's a lot of parts in contact. And one thing I want to note is that these get created automatically for us. We might have to go in and confirm some of these, and the default behavior is bonded, but you could change it over to no separation if you want. But those do get created automatically, which I'll show in a moment how that happens. Past that, we go into the Refine Model tab, which gives us a few more things to use. First, we have joints, right? And what joints are, if we just edit this, for example, let me get, oh, it's gonna be in the translational. So you have a shock tube and like a piston type situation here. And so what these joints are doing is it's letting us describe, what is gonna be fixed. So we're saying this grayish part is gonna be fixed or stationary, and what's able to move, which is this silver portion of the shock. And it will push down as our force comes down. But like I said, these are going to be frictionless types of joints. So there's not going to be any resistance to it pushing down. It's just going to push down as far as it can, given the force loading you have. And on top of that, the other types of joints we have, right, are realistically anything. So you could create your own type of joint and describe how your bodies will be fixed or free along our X, Y, and Z axes or rotationally. But there's also predefined joint behaviors for us. And these are very similar to like our assembly constraints. So like hinges or slots, and those just have predefined degrees of freedom restrictions, which we see in our joints. We have some hinges and translational, so up and down movement. And we'll see how those work specifically when we see our results. We also have idealized springs, right? So those are created, giving specific spring behaviors. You can define out how the spring type works. Give it a spring length, specific spring stiffness values. And you can connect things via a spring. Now, past that, if we come into our mesh control, here's where we're able to play with our mesh values. So if I click on global mesh size, we see we have specific values here. But if I lower my mesh resolution and then click on my mesh size, we see that it changes those values to create a more loose mesh. And so that's what this slider lets us do. And we can also insert our own values if you want here. You can select specific areas of our model and define out, how our mesh, if we want to refine certain areas along an edge or along a surface. Then we can go in and generate it. We can also display our mesh, which I'll do here real quick. My Might take a moment to show up, seems. It might come shortly. I don't know why it's not showing here right now. Yeah, we'll see. Now, past that, we do have our results that we can look at. So in this case, all I have here are some basic results. And so if I were to activate like my von Mises stress, what we'll see is that our model will update. So it comes to like a wireframe, and then the contour of the colors should apply here. Yep, there they are. And so we can see our model stresses. We could zoom in, and our legend is over here on the right, and we could change, what we're looking at based on what results we have defined, as well as the units. So we'll default to whatever units your part model is in. Down here at this icon, we could show where our min and max values are. So what I want to show here is if we were to look at our displacement magnitude, for example, right, we'd see all the colors pop in, but we don't see our actual deflected shape. And that's because we did not create an advanced result. So these basic results, again, always get created. But if we want to see things like deflection or see something more unique, we'd have to create an advanced result, which I'll show here in a second. So that's our results. And so again, or to kind of show if I wanted to define like a contour plot, we could define the full displacement, click OK. And what we'll see is that our results on our simulation tree have a little like clock icon. What that's telling you as the user is that, hey, you defined a new result, and we don't need to rerun the whole simulation. We have the mesh defined and we have results already, but we do need to update our results because you created a new window. So you can right click and click update. And what this will do is actually go through and update our part model, our results section. While that goes, I think I already have it. Let's give us a moment here. So let me switch windows. There it goes. Okay, so I'll switch over to this study. It's currently glitched out. There it goes. So if I come to this structure study and look at my advanced result that I already defined here, let's look at my displacement magnitude and activate it. We'll be able to see our result. And this one is already run, so it should show. But it's not. Okay, well, we'll wait for the other one to show that result. The other thing I wanted to show real quick is, how do these contacts get created, right? So all these bonded interfaces. Well, when you go to create a new study, so if I like add a structural study and click next, you see that automatic contact detections get picked up, and that's what's actually going to find all those contacts for us. And so we can create, multiple studies depending on our model. So for example, here I also created a modal study, and I just fixed on my model the same. I have the same contacts, and so if we activate our results here, what we're able to see in this model, I don't know what the color, there must be some graphical issue happening here, but what we are able to see is all the modes. And so if I were to edit definition, we can see all my modes, my natural frequencies that got calculated out here. And by default, it's only going to do the first 6 modes, but you could change this as you please. If you want to see more modes, you can, increase that. And that's some of our modal studies. Let me go back to this model here and see if it's updated. Looks like it did. So let me activate my displacement magnitude. Give it a moment. There it goes. Okay. And so what we see is this motion happened, and we see the actual, because it's an advanced result, it's actually showing us the displacement of the model. Down here, in this toolbar, we can actually control the speed of it. And I can, play it, and so we could see it, coming down. And so those joints behaviors is what you can see here as a good example, is because that joint was created here, this tube will move into the shock, or the shock will move and is stuck based on how we defined the joint. You can see the rest of the motion like that. And using our legend, we have a few more options in the advanced results. For example, we could turn off the blended results. We could control the values. Also how many colors are. So those are all things we can control for our legend still. And we could define out like probes we desire. So let's do maximum like a surface. And these are things that also need to be updated. So if I create a probe, it will need to take some time here to actually calculate the value, or we will need to actually refresh the result to do that. And so last things are, well, that's working. Let's come back over to this model. So if I come to save as, here's where you can actually export to a mechanical project file. Now, if you're familiar with ANSYS, you might not recognize, this exact file type, and that's because it's unique to, I think it's unique to Creo, something that they developed together. But this is how you can save your study, which will allow you to import it into ANSYS Mechanical. Past that, what we're able to do is save as and save our simulation data. And that's what's actually going to create an APR file, so an ANSYS project file. And what that is that is what your current study is saved to. And so you can actually open up this APR file, which will open up your full study for you. It will open up your part into ANSYS Simulation, and you can begin working from there. Save your simulation data there. Back here. See if this didn't work out. And that is overall a little bit of a deeper dive into Creo ANSYS Simulation and kind of showing some of the more advanced functionalities we have. So let me come back to my slide deck. Let's go to my next slide. And so if you're interested, we are going to be creating or doing a class on this topic. It's currently scheduled for May 12th to May 14th. And we do have trainings available virtually in center or on your company sites. And so we will be offering training for the software that will include, much more than was covered in just today's little webinar. But past that, I want to open our floor up to any Q&A, which again, you can either put in the questions pane or in the chat. We'll read both. If you think of questions down the road, my email is on the screen there. And you can reach out to me and I can, help answer any questions or guide you in the right direction. We also have our sales email up there. And past that, this webinar, along with a bunch of other webinars, are currently on our YouTube. So if you just go to youtube.com and type in like boundary systems, you'll be able to go to our YouTube page where we have, weekly webinars on a wide variety of concepts. So you can check those out there, as well as our URL at boundarysys.com. And so that is pretty much it for the webinar. So I will wait and see if we have some questions here. So the question I just saw, it's a pretty good one, is this ANSYS simulation tool intended to replace Creo Simulate? And in its current state, no. So this tool is made in partnership with PTC or with ANSYS. And so the tool is not made to actually, or is not set to actually replace Creo Simulate. Creo Simulate will be supported in the indefinite future. There's no plans to sunset it. But that being said, PTC's is more motivated, or is the new additions for simulation tools will be incorporated into this Creo ANSYS tool. updates to Creo Simulate are more so going to be in line with like fixing bugs or fixing any issues seen with current models. But new functionalities will be focused on this new Creo ANSYS simulation tool. But overall, no, Creo Simulate is not going anywhere. It will still be here. Another question is, what kind of license do we need for this? So this is its own license, so that needs to be purchased. It's like it's a extension license that you need to purchase. That it comes on. It doesn't like come with Creo by default. It is something you need to purchase. So yeah. So it seems like all the questions are in. If you have any last minute things, throw them in the chat or the questions pane. But again, my email is up here. If you think of any questions, oops, in just 2 minutes after this is over, you think of a question, feel free to send me an email and I'll get back to you any kind of response you need about this. But with that in mind, it seems our questions are done. And I will be closing out the webinar. So I hope you all have a great rest of your day.